Boys and girls, we're going to find out the resistance of this equivalent resistance of this circuit. From my last lecture, the total equivalent resistance of the circuit is R equal to 4 plus 20 by 9 ohm. If I calculate this, then total resistance becomes 4 plus 20 divided by 9. It will equal to, in fractional format, decibel format, 6.22 ohm is the total resistance of this circuit. Now I'm going to find out the electrical power of resistance R1 and R4 in question number D. The question was, do you think electrical power of resistance R1 and resistance R4 will equal? I'm going to show this, it will be equal or not. Now, before find out their power, at first I am to find out the electric current of the circuit, total current of the circuit, okay? So, total electrical current I will equal to, by applying Ohm's law, that is E divided by R plus small r. Boys and girls, you know already very well, here I is the total electrical current of the circuit, E is the electromotive force, R is the resistance, capital R, and that is called external resistance, and small r is called internal resistance of the battery. For the case, by considering ideal case, there is no internal resistance given in the circuit. That means the value of small r will equal to 0. Now, electromotive force E will equal to 40 volt. That is given in this circuit equal to 40 volt, and total resistance R, that is external resistance of the circuit, this will equal to 6.22 ohm, and the internal resistance small r, that will equal to 0. So the total current, that means circuit current, is 40 divided by 6.22 will equal to 6.43 ampere. 6.43 ampere. Now, in next segment, I am to find out electric power of R1 and R4. Before find out electric power, I need to know about the voltage drop in between point AB and in between point CD. In first step, I need to find out the voltage drop in between AB point. So, voltage drop V in between AB, that will equal to V equal to I into R. So, in between AB, total amount of current I1 plus I2, that will equal to I passes through. So, V will equal, I can say that I into the resistance of this part, and this resistance will equal to RP1. I repeat, this resistance will equal to RP1, that I already find out in the first segment in question number C, RP1. So here I equal to total current 6.43 and RP1 equal to 2 ohm. So total voltage drop or consumed voltage in between AB part, that is 6.43 into 2 will equal to 12.86. 12.86 is the voltage drop in between AB part. Now, I want to find out the electric power of resistance R1. So, this power P1 will equal to, there are various options here, you know already very well. Electric power P will equal to VI, then V square divided by R, then I square into R. So, which option you want to choose? First one, P equal to V into I. You know the voltage drop in between ABV, but you don't know about the electric current I1. You want to find out this? So we need to know, we don't use this step. The next step, V square by R. So here resistance R1 is given, and here voltage drop in between AB is also given. So we must use this step to find out electric power of resistance R1. In next step, we don't know about the particular current of R1, so we don't use this third step. Now, for first step, electric power of resistance R1 P1, that is P1 equal to VAB square divided by R1. Why? Because R1 stands in between AB part of the circuit. So in between this AB part, the voltage drop is here 12.86 ohm. So 12.86 ohm square divided by the particular value of R1 is 4 ohm. So this will give you the total power of the resistance R1. So 12.86 square divided by 2 divided by 4 will equal to 41.34 watt is the electric power of resistance R1. In next step, to find out electric power of resistance R4, boys and girls, to find out electric power of resistance R4, you see here, you need to find out the voltage drop in between CD part. So voltage drop in between CD part, because R4 stands in between CD part of the circuit. CD part will equal to total current I into RP2, because the equivalent resistance of R4 and R5 will equal to RP2, and the total amount of current flowing through this part is I. Now V of CD will equal to I into RP2. Here total current I will equal to 6.43 into RP2, and the value of this RP2 will equal to 20 by 9, 20 divided by 9. So total voltage drop, that is 6.43 into 20 divided by 9 will equal to here 14.29 volt. Now I have to find out power of resistance 4, that is R4, will equal to V square, so V of CD square divided by R4. Now V of CD will equal to 14.29 square, and the value of fourth resistance R4 will equal to 4. So 14.29 square divided by 4. So total power is here 51.05 watt. From this discussion, you can say that electric power of R1 is 41.34 watt, and electric power of R4, that is 51.05 watt. So their electrical power are not same or are not equal. Now, boys and girls, in next page we are going to solve another creative question. You see, in this part also a circuit is given, and there are 4 questions. Question number A, what is called electric power? It will carry 1 marks. We will discuss this topic, electric power. In question number B, why silver wire is used instead of copper wire in high voltage electric wire? It will carry question marks 2. In third step, calculate electric power of the circuit. It will carry electric current of the circuit. It will carry number 3. And question number D, do you think voltage drop of resistance R2 and R3 are same? It will carry marks 4. So in this segment, in this part, I am to discuss question number C and question number D. In question number C, I am to calculate equivalent resistance of the circuit. You know, when electric current divides, then this in between this divide part, listen to me, in between this divide part, those resistance are connected in parallel connection. So here R2, R3, R4 are connected in parallel connection with with resistance R1 in series. Now, equivalent resistance of R2, R3 and R4 will equal to Rp. Equal to, you can say that 1 divided by 1 by R2 plus 1 by R3 plus 1 by R4. Now, put the value of R2, R3 and R4. 1 by R2 will equal to 1 by 12 plus 1 by 10 plus 1 by 5. So, if you make LCM here, then you can say 5, 10 and 12 will be 120. So 120 divided by 12 will equal to 10 plus 12 plus 120 divided by 5. 120 divided by 5 will equal to 24. Now the whole part becomes 120 divided by 24 plus 12 plus 10 equal to 46. So equivalent resistance of this part becomes 22.61 ohm, and this equivalent resistance will connect it with R1 in series connection. So total resistance of this circuit R will equal to R1 plus Rp. So R1 equal to 10 plus Rp equal to here 2.61. So the total equivalent resistance becomes here 12.61 ohm is the equivalent resistance of this given circuit. Now, boys and girls, we are going to solve question number D. In question number D, you see here voltage drop in between R3 and R2 are same. You want to justify this. So before justifying this, at first I need to know the total current of this circuit, and then I can easily find out the voltage drop in between R2 and R3. Say this is point A and this is point B, and you know here given electromotive force is 50 volt. Given electromotive force is E equal to 50 volt, and total equivalent resistance becomes R equal to 12.61 ohm. And from previous part, the equivalent resistance of the parallel connection is 2.61 ohm. Now, before find out voltage drop in between R2 and R3, at first I need to know the total current of the circuit, and total current of the circuit I will equal to E divided by R plus small r. You know, boys and girls, here E equal to electromotive force, that is 50 volt, and capital R equal to 12.61 ohm. You already find out this in question number C. So that is 12.61 ohm plus 0 will equal to 50 divided by 12.61 will equal to here 3.97 ampere. Now here R2, R3, R4 are connected in parallel connection, so their voltage drop in between AB part are same, so they'll experience same amount of voltage. So in next step I have to find out the voltage drop in between AB part. So voltage drop in between AB part will equal to I into Rp, because here equivalent resistance is Rp and total voltage drop in between these two part is V of AB. So I equal to 3.97 into Rp will equal to 2.61. So into 2.61 will give you 10.97 10.35 volt. So voltage drop in between every part is 10.35 volt. Boys and girls, here R2, R3, R4 are connected in parallel connection, so their voltage drop are same. And on the basis of this statement, we can say that voltage drop of R2 will equal to voltage drop of R3 will equal to voltage drop of R4 will equal to V of AB, and that must be here 10.35 volt. Finally, you can say that the voltage drop of these three resistance are same. In next step, boys and girls, we are going to give you some homework. Creative question number 3 and creative question number 4. Boys and girls, in creative question number 3, question number A is what is called electric current. Question number B, why electronic device does not support Ohm's law. Question number C, calculate equivalent resistance of this circuit. Question number D, do you think electric power of R1 and R4 are same? Explain mathematically. And then creative question number 4. In creative question number 4, there is also a circuit is given here, and under the circuit there are 4 questions. One is what is called electric power. Question number B is why silver wire is used instead of copper wire in high voltage electric wire. Question number C, calculate electric current of this circuit. Question number D, do you think voltage drop of R2 and R3 are same? Explain mathematically. Summary of this class. After this class, you can solve creative question on current electricity chapter. Thank you very much, boys and girls. Thanks to all. But remember, try to solve your homework, that is creative question number 3 and creative question number 4 properly. Thanks to all.